Okay, guys, next thing we're going to talk about is electronegativity. Now, I went on ptable.com and I clicked on properties and then I clicked on electronegativity here, and it pulled up this periodic table which looks a little bit different than what we have been looking at because it's labeled for our electronegativities. The darker it is, the more electronegative. Now, the one thing we need to know about electronegativity is its definition. Okay, it's the amount that an element will pull on a shared pair of electrons. The main thing is this: it's when it's in a chemical bond. Okay, now if it's not in a chemical bond, it's not going to have an electronegativity. So when we look at these guys over here, group 18 are noble gases. Remember, they're unreactive. Okay, so they're not going to have electronegativities. Now, we do have an exception down here with krypton and xenon, and it's just in very special circumstances that they are going to have electronegativities. But in general, everything is going to increase as it gets closer to fluorine. Generally, what we say is it increases across the periods and up in our groups, the highest being fluorine. So an example, if we were to say what has a higher electronegativity, oxygen, sulfur, selenium, we would say that oxygen is the highest, and then it would be sulfur, and then it would be selenium, because the higher up it is, the more electronegative. If we were going across a period, what had a higher electronegativity, potassium or calcium? Well, calcium would be the highest, and then it would be potassium, because calcium is closer to fluorine.